In the vast expanse of our solar system, amidst the swirling planets and glittering stars, lies a celestial object of great intrigue, Pallas. This asteroid, often overshadowed by its larger counterparts, holds a unique place in the cosmic ballet of our solar system. It is the third largest asteroid, a remnant from the early solar system's formation. Unlike many other asteroids, Pallas has a slightly tilted orbit, making it a fascinating subject for astronomers and scientists alike. Pallas is more than just a space rock. It is a time capsule, holding clues to the events that shaped our cosmic neighborhood billions of years ago. Its surface, marked by craters and ridges, tells a story of countless collisions and cosmic events. Its unique characteristics and mysterious origins have captivated astronomers for centuries, beckoning us to unravel its secrets. The quest to understand Pallas is not just about the asteroid itself, but about piecing together the history of our entire solar system. Pallas stands as a testament to the dynamic processes that governed the early solar system. The chaotic environment of the early solar system saw the formation and destruction of many celestial bodies, and Pallas is a surviving witness to those turbulent times. Its discovery opened up a new realm of exploration, revealing a belt of celestial bodies between Mars and Jupiter. This asteroid belt is a treasure trove of information, each asteroid a piece of the puzzle in understanding our solar system's past. These asteroids, including Pallas, are remnants of a failed planet, fragments of a bygone era that hold the key to understanding the formation of our solar system. They are the building blocks that never coalesced into a planet, offering a glimpse into what might have been. The study of Pallas provides valuable insights into the composition and evolution of our solar system. By examining the minerals and elements found on its surface, scientists can infer the conditions that existed when the solar system was young. By analyzing its surface features, mineral composition, and orbital characteristics, scientists can piece together the story of its formation and the conditions present in the early solar system. Each crater and ridge on Pallas is a chapter in the story of our cosmic origins. Each new discovery about Pallas brings us closer to understanding our own planet's origins. The more we learn about this ancient asteroid, the more we uncover about the processes that led to the formation of Earth and the other planets in our solar system. The journey to unveil the mysteries of Pallas is a journey to understand our place in the universe. On a clear night in March 1802, German astronomer Heinrich Wilhelm Olbers was meticulously surveying the night sky. He was searching for a celestial object predicted by the Titius-Bode law, a mathematical formula that suggested the existence of a planet between Mars and Jupiter. What he found, however, was not a planet, but a faint star-like object moving against the backdrop of distant stars. Olbers had stumbled upon the second asteroid ever discovered, Pallas. Its discovery sent ripples through the scientific community, challenging the prevailing understanding of our solar system's structure. The existence of Pallas, along with the previously discovered Ceres, hinted at a vast belt of celestial bodies orbiting the Sun between Mars and Jupiter. The discovery of Pallas was a pivotal moment in astronomy, marking the beginning of the exploration of the asteroid belt. It sparked a wave of new discoveries as astronomers raced to uncover more of these celestial wanderers. With each new asteroid found, our understanding of the solar system's formation and evolution grew. Pallas is an enigmatic celestial body with distinctive physical characteristics. It is the third largest asteroid in the main asteroid belt, with an estimated diameter of about 512 kilometers. This makes it roughly the size of the US state of Arizona. Unlike most asteroids, which are irregularly shaped, Pallas is relatively spherical, suggesting that it may have once been a protoplanet. The composition of Pallas is believed to be a mixture of rocky materials and water ice. Spectroscopic observations suggest that its surface is covered in hydrated minerals, indicating the presence of water ice beneath the surface. This makes Pallas a valuable target for future exploration, as it could provide insights into the distribution of water in the early solar system. The surface of 2 Pallas is heavily cratered, bearing witness to a long history of impacts with smaller asteroids and meteoroids. These craters vary in size and shape, providing clues about the types and sizes of objects that have collided with 2 Pallas over billions of years. Studying the crater distribution on 2 Pallas can help scientists understand the dynamics of the asteroid belt and the impact history of the early solar system. Section 4. A unique path. 2 Pallas' orbit and position in the asteroid belt. In this section, we will delve into the fascinating orbital characteristics of 2 Pallas, one of the largest asteroids in the main asteroid belt. 2 Pallas orbits the Sun in the main asteroid belt, located between Mars and Jupiter. This region is teeming with countless rocky bodies, each following its own unique path around our star. Its orbital period is about 4.6 Earth years, meaning it takes 2 Pallas approximately 4.5 years to complete one full orbit around the Sun. This extended journey is a testament to the vast distances and slow-moving nature of objects in the asteroid belt. Unlike most asteroids in the asteroid belt, which have relatively circular orbits, 2 Pallas follows a highly inclined and eccentric path. This deviation from the norm makes it an object of great interest to astronomers and scientists. The inclination of 2 Pallas' orbit is about 34 degrees, which is significantly higher than the average inclination of asteroids in the main asteroid belt. This steep angle means that 2 Pallas travels above and below the plane in which most other asteroids orbit. This means that 2 Pallas' orbit is tilted at a steep angle compared to the plane of the solar system. Such a pronounced tilt is unusual and suggests a complex history of gravitational interactions. The eccentricity of 2 Pallas' orbit is also high, meaning that its distance from the Sun varies considerably throughout its orbit. At its closest approach, or perihelion, it is much nearer to the Sun than at its farthest point, or aphelion. The unique orbital characteristics of 2 Pallas make it a fascinating object to study. Its path through space is a window into the past, revealing clues about the early solar system. Its high inclination and eccentricity suggest that it may have been gravitationally perturbed by Jupiter or other massive objects in the early solar system. These interactions could have significantly altered its orbit, pushing it into its current unusual path. The study of 2 Pallas' orbit provides valuable insights into the dynamical evolution of the asteroid belt and the gravitational interactions between asteroids and planets. By understanding these interactions, scientists can piece together the history of our solar system and the forces that have shaped it over billions of years. Section 5. A protoplanet's tail theories on the formation of 2 Pallas. The formation of 2 Pallas is a subject of ongoing scientific debate. This asteroid, one of the largest in the asteroid belt, has intrigued scientists for decades. Its unique characteristics and composition have led to various hypotheses about its origins. One prevailing theory suggests that 2 Pallas is a remnant of a protoplanet, a large planetary embryo that formed in the early solar system. Protoplanets are the building blocks of planets, and 2 Pallas might be a glimpse into the past, showing us what the early stages of planet formation looked like. According to this theory, 2 Pallas accreted from the solar nebula, the disk of gas and dust that surrounded the young Sun. This nebula was a chaotic environment, with particles constantly colliding and sticking together, gradually forming larger bodies. As 2 Pallas grew in size, its gravity attracted more material, eventually becoming large enough to differentiate into distinct layers. This process, known as planetary differentiation, involves the separation of a planet's interior into layers of different compositions and densities. However, unlike the inner planets, which were able to accrete enough material to become full-fledged planets, 2 Pallas' growth was stunted. The reasons for this stunted growth are complex and involve various factors, including the distribution of material in the early solar system. The gravitational influence of Jupiter, the largest planet in our solar system, is thought to have disrupted the formation of planets in the asteroid belt, preventing 2 Pallas from reaching its full potential. Jupiter's immense gravity could have scattered material, making it difficult for protoplanets like 2 Pallas to gather enough mass. Another theory proposes that 2 Pallas may have formed through the collision and reaccumulation of smaller asteroids. This idea suggests that Pallas is not a single undisturbed body, but rather a conglomerate of many smaller pieces that came together over time. In the chaotic early solar system, collisions between asteroids were common. These collisions could have shattered larger bodies into smaller fragments, which then reaccumulated to form new, larger asteroids. It's possible that Pallas is the result of a series of such collisions, with smaller asteroids merging to form a larger body. This process would have been violent and chaotic, with pieces of rock and metal constantly colliding and sticking together. The heat generated from these collisions could have melted the interior of Pallas, allowing it to differentiate into layers. This melting would have caused heavier materials to sink to the center, while lighter materials rose to the surface, creating a layered structure similar to that of larger planets.